Okay, we've just opened up our session here, so I'll just give a couple of seconds here for the attendees to start jumping on, and we'll get this thing kicked off. All right, looks like we got some numbers are popping up here. So, all right, everybody, this is Cody Cochran with MBSI WAV. So we're really excited. This has been a long time coming. Our third and final session along with Cambium Networks is a part of our hat trick series, we're calling it. So Stanley Cup final time, so perfect time to wrap up our hat trick series. Today's session, we're going to be introducing the Cambium 60 gig platform. So a little bit more on that here in a bit, but I just need to do some housekeeping on the webinar here before we move forward. Just keep in mind, of course, MBSI WAV, we are a proud stocking distributor of all the Cambium Networks products. So the housekeeping, so our webinar today will be recorded and uploaded to all of our social media outlets shortly after we complete here today. You can check it out on our YouTube, LinkedIn, Facebook. We will have a post there, so if you do have to step away or get distracted, no problem. If you have any questions or comments, please do drop them in the chat window as we move along. We'll try to address as we go, but we will have some time at the end of the session to answer any questions we might not get to as we move along. Again, if we do run out of time for the Q&A period, we will make sure to personally reach out and address any questions that might be outstanding. If that chat window does not open automatically, there is an icon at the bottom of the window to open that up. So please pay attention during the webinar today. We will be asking a skill testing question at the end of the session. The first person to answer correctly will win a $100 NHL Shop gift card. To be eligible for the giveaway, you do have to be a resident of Canada. We do, of course, love our friends south of the border, but this is just reserved for Canadians here. So here at MBSI WAV, we're super excited for the Cambium 60 gig platform. There's a ton of excitement for the Teragraph chipset as a whole. I really feel like this is going to be a huge game changer for anybody who deploys fixed wireless in any kind of scenario, application, vertical, etc. Just so everybody knows, we have placed our very first stocking order with Cambium for the 60 gig products, and we are in a position to take pre-orders right away. If you want to get your hands on this equipment sooner than later, we really do recommend you get in touch with your salesperson here at MBSI WAV and work with them on building a BOM and getting an order in, as there's going to be a ton of demand for this product. Again, MBSI WAV, we can help you with the planning, network design, post and pre-sale support on any piece of a wireless network, including the 60 gig. Ryan and Dave Collins have been very busy doing some design work already. So with that, so presenting today on behalf of Cambium Networks is Alan Yu. Alan is a Director of Product Management, over at Cambium Networks. Fantastic to work with, very supportive. And with that, Alan, since we're wrapping up our hat trick series today, you're on the breakaway, so bring it home, brother.
Okay, thank you, Cody. Good morning, good afternoon, everyone. I'm very glad to be here. Thanks for MBSI WAV to invite me here. And today I will try to give you an overview about 60 gigahertz, what is the new standard thing, and of the 11AY more specific. And also I will give a quick overview about Cambium cnWave product. So 60 gigahertz it's not really something new. I mean, 60 gigahertz has been existed for a while, and people using 60 gigahertz for point-to-point. If you look at Canada specifically, the regulatory SED, which is the Canada industry in the past named, they have a specific regulatory document covers the 60 gigahertz, the RSS 220, RSS 210 in the Annex J. It also specifically tell what is the regulatory rule need to follow, what the channel size, what the frequency available. You can see in Canada, it's very similar like what we have open here in the United States as well. The whole 57 to 71 gigahertz, which is like 14 gigahertz spectrum opened for this 60 gigahertz band. And totally there is 6 channels we can fit in, and every channel with 2.16 gigahertz. And this is widely available across the whole Canada. It's unlicensed band. So when you deploy this, you don't need to worry about licensing process. It's all unlicensed spectrum. So, I mean, we talk about a little bit high level about what's the pros and cons for 60 gigahertz. So unlike people familiar with like sub 6 gigahertz, the 5 gigahertz band, you know, normally we talk about longer range. 60 gigahertz is only available for short range, and also it's basically only do line of sight, which is kind of like you know, people think this will be a little bit limitation, but instead if you really think about you want to do high capacity deployment, and this short range become a good thing because due to the oxygen absorption, the signal will not transmit far away, and the signal will be, you know, only populated within a certain range. The frequency reuse will become a positive thing because of the oxygen absorption. And also, you know, with the mesh, we will be able to extend the range, you know, overcome the line of sight. So that kind of like, you know, we have the way to overcome that. On the positive side, first, it's unlicensed band. Compared to 5 gigahertz, we have much wider channels available. So even with kind of like low modulation, BPSK, the lowest modulation, we can still support 380 megabits full aggregate. And also 60 gigahertz, because the frequency is very high, we have a much smaller radio. Because antenna, even antenna is small, the antenna gain is still pretty high. So if you look at the 60 gigahertz radio, the typical like SM we built, we call cnWave 1000. It's about the size of your hand. So this very, and also we can also do beamforming using the patch panel antenna. So this really give us a lot of advantage using the 60 gigahertz. Last one, we talk about oxygen absorption, we talk about line of sight thing, and this makes the frequency reuse high possible because we have less reflection thing happens, and the narrow beam is much narrower. Together, the signal is not spread everywhere. It's really within a certain range. So the frequency reuse is a big, you know, improvement on the 60 gigahertz band. Let's talk about a little bit more thing about 60 gigahertz. A very unique stuff about 60 gigahertz is the oxygen absorption. You know, we know when we go higher frequency, the signal will be impacted by rain, but for 60 gigahertz specifically, you know, you can see there's a peak on here. Basically, the oxygen absorption will really add additional attenuation. We talk about 12 dB per kilometers extra on 60 gigahertz itself. So compared with the E-band, when we move to 70, 80 gigahertz E-band, actually they have less impact for oxygen absorption. Then, you know, that is why on 60 gigahertz we're talking about even shorter distance. And the 80 gigahertz actually can go a little bit longer. We talk about, you know, 1 to 3 kilometers instead of like in 60 gigahertz. We talk about even for a point-to-point, we talk about 1,000 kilometers. So the really short distance. The other thing, the second topic I want to touch is about the standard. So our product using the 11AY. So what is the 11AY? 11AY is a new 802.11n standard coming from IEEE. The AY is not fully published, but the standard is pretty much set, you know, finalized, and we expect 11AY will be finally published in this year. Given the pandemic, I think things are moving a little bit slow, but it's coming. On the 11AY, compare with the you know, pre-version, which is the 11AD, which is you know, published in 2016. There are feature function improvement defined in 11AY. More specifically, 11AY is trying to provide a better network performance rather than just simply, you know, improve like you know, channel size and other things. You can see in the AY, they did using the channel bounding, so we are able to using wider channel to deliver high capacity. But more importantly, AY defined a totally new MAC and PHY layer. So we do the TDMA versus CSMA defined in 11AD. Also 11AY add network synchronization, which is a big thing when you have high density deployment. And both the TDMA and network synchronization also make the whole network much better organized in a structured way. This really gave a good foundation for mesh support, because now we have the whole network, interference in a better controlled mode, and every radio transmitted in a synchronized way, and we have the throughput much better predictable, and then make the mesh routing more reliable, because now the system is more organized. So that's really a big difference compared to AY versus AD. So what's this really convert to us, right? We talk about this things kind of, those are the new things defined in AY, but why is benefit? The benefit of the new MAC and PHY is really to improve the throughput, to have a more guaranteed throughput per every radio. It also, because we remove this CSMA access, and this really give a more stable or lower latency and low jitter. Unlike the CSMA, if you have more customers, then due to the high confliction, you're probably gonna wait for a long time to transmit. So the latency and jitter could be very bursty. And this new MAC, the TDMA, TD, really makes things much easier. Synchronization is make every radio transmit and receive in the organized way. So we can we can minimize the interference. We can also improve the frequency reuse. With our design, we can support single channel per network. This really makes things much organized, more scalable for the future deployment. Channel bounding, higher capacity. We can double the capacity using the same hardware, simply just using these wider channels. And with all of that, this really help us to do the mesh, which give you the auto heating, auto expansion. Is a big benefit brought in by the 11AY standard. So let's talk about Cambium. We're very happy to announce our cnWave product line. As Cody mentioned, we are, MBSI WAV already have pre-orders, and now we're able to taking orders for any customer. If you're interested to deploy to the, the cnWave 60 gigahertz, you're willing to, do the POC. Now we're ready to take the orders. So our product is 11AY based and with mesh support, and we're also Telegraph certified. We have 3 products we're introducing, the V5000, which is the DN node. The DN node is used to act like an access point, so we can serve a multipoint with multiple CN nodes. In addition, our distribution node can also form a mesh layer, so you can, using the mesh to extend your coverage. You can also do load balancing from your fiber pop site, and then, there to propagate your traffic across the network. Our radio support beamforming. We can do easy installation. The V5000 has a coverage for 280 degree. The V1000 has a beamforming for 80 degree. And the V3000 is the long range client node. We do the beamforming for 4 degree because we have a pretty high gain dish, the 44.5 dB antenna there. Easy operation. We do the zero touch provision. All the things will be pushed out from the network side through the end-to-end controller and our CN master NMS. So all the configuration will be pushed down. This will make the installation far easier. You don't need to worry about, what I need to set up for my radios. You literally just need to know your MAC address, and then all the things will be pushed down from the top. In the case you need to replace a failure hardware in the future, you don't need to worry about configuration backup. Again, things will be already saved in the system. It will be pushed down. So it's zero touch provision is very helpful, makes things much easier. Last, all the radio are software configurable. So we can do point-to-point, point-to-multipoint, or mesh configuration. All the radio can define the function through the UI interface. With that, let's talk about applications. So 60 gigahertz, we talk about high capacity line of sight, short range application. When we down to specific applications, we talk about wireless to the home. Let me move this one a little bit more higher. So we talk about wireless to the home, wireless to the building, and also rooftop to rooftop. What it really means is, we can serve individual residential customers. We can also serve people's lived shared a building like apartment in the urban or in the suburban area. People share apartment for a building. We can feed the high-speed internet to the building, then using the indoor infrastructure to distribute the internet to every house. We can also do rooftop to rooftop connection to point-to-point or point-to-multipoint. That can be done, basically serving the campus connection, or an enterprise business. They want to connect their factories to their office, like that. Some retail business, they want to connect their store to the nearby gas station. Those are all typical applications people can use. We can also do the fiber extension, because our radio, when we do the channel bonding for a point-to-point link, we can deliver 7.6 gigabits, and each direction is a 3.8 gigabits throughput. You can do the last couple hundred meters extension from your fiber place. You can also use this one as a backhaul to do the 5G small cell, outdoor Wi-Fi. When people trying to connect a smart city, we doing the video surveillance. We can also backhaul those cameras and to deliver very low latency, very high capacity distributed backhaul layer to serve those backhaul purpose. On top of that, we have the CM Maestro as a single panel for network management. If you're using the Cambium gears, we have the CM Pilot for Wi-Fi, indoor and outdoor Wi-Fi. We have the CM Maestro. We have the cnWave. We can do the backhaul layer, and then you think about we can do the using the 850 line E-band radio to deliver high capacity for microwave thing. And also we have CM Matrix. CM Maestro can manage all those devices from a single place, give you a complete end-to-end solution. So that's where you can see we're not just provide a box, we're provide a complete solution. Talk about applications. We see this one can be used for urban deployment, to serve in house, to serve the residential, to serve the buildings. We can also deploy this radio in the suburban areas for either the residential connection, or we can serve the enterprise industrial who want to make the campus connection, school connection, factory connection. This can also be achieved by cnWave 60 gigahertz. When we move this one out of the rural area, generally speaking, we're not trying to use 60 gigahertz to solve the coverage, because it's a small range point-to-multipoint or point-to-point technology. What we really see is using the 5 gigahertz to solve the coverage in the rural area. But for the people lived in the village, or the living in the community has higher density, you could using 60 gigahertz there to cover a hotspot or offset the traffic from your existing 5 gigahertz. So using the 5 gigahertz solve the coverage issue, and using the 60 gigahertz really provide us high capacity need for your customers. Talk about the specific product details. We're gonna jump into the V5000 first. V5000 is a 2-sector distribution node. We cover 2 sectors, and every sector covers 280 degrees. And every sector can support up to 15 devices. So with 2 sectors, we can support 30 devices. And the hardware is ready for IEEE 1588 transparent clock. This will be a feature supported in the next year. Same thing for channel bonding. This is hardware ready. The channel bonding will be a firmware feature available next year. On the interface wise, we have 3 ports. We have one main port for power supply. This is also a 10 gig, up to 10 gig copper interface. So we can power the radio through this PoE port. The second port is a copper 1 gig auxiliary port with PoE out as well. So from this port, we can power outdoor Wi-Fi device. We can also power a camera thing. The third port is a SFP plus slot, and we can terminate a 10 gig fiber module here, or we can also terminate the GPON module here. So in the case you want to do a single cable installation with PoE in, you can run a Cat6A cable with 10 gig copper and using the single PSU port. In the case you want to go with a fiber, then you have the choice either using we offer a DC to RG45 mini adapter. So you can have the DC in, and then we will convert to RG45 interface. So you can power the radio directly with DC input. And that is also a second choice or alternative configuration if you want to do with a fiber setup. When we move to the V3000, V3000 is a high gain client node. It can also be used for long range point-to-point applications. And with a single 2.16 gigahertz channel, we can support 3.8 gig aggregate throughput, 1.9 gig down and 1.9 gig up. With channel bonding, we simply double the capacity. We're managed to have the beamforming supported in V3000, and I believe we are the only radio today in the market to provide high gain with beamforming capability. The beam width itself is about 0.8 degree for in horizontal, but with beamforming, we make the scan range become 4 degrees, so it's five times better or 5 times wider than its 0.8 degree beamforming. With that one, it's not only help you during the installation to find the alignment quicker and easier, and more importantly, even after installation, because we have this auto beamforming running all the time, we will be able, even let's say you have the storm or something happens, the radio has a little bit twist, the radio will still maintain the best performance because the auto beamforming is happening on both ends, and we can continue keep the radio aligned in perfect mode. Then on the interface wise, it's very similar. Almost, literally it's identical compared with V5000. So we have 3 ports there. We have the fiber interface, copper interface, and auxiliary port. You can power an outdoor device, a camera or a Wi-Fi thing. So move to the V1000. This is a mid-gain client node. The radio is pretty small. It's if you look at the size, it's 140 by 85 by 40 millimeters for the 3D dimension. The power consumption is about 10 watts. Our radios were IP66, 67 rated for outdoor use. And for this device, we basically offer a single interface for up to 1 gig copper interface with 8023AF PoE in to make this one very simple, easy for alignment and installation. During the installation, really, if we're doing either a point-to-point with itself or a point-to-multipoint with V5000, the alignment work is pretty much you just need to point to the right direction instead of you really need to do the best alignment thing, because the beam width is pretty wide. In the first release, we're not support the point-to-point using V1000 yet, and V1000 will be released in the release 2, which is about 3 months after release 1. At that time, you will be able to using 2 V1000 to form a 1 gig connection for short range. So configuration-wise, we talk about point-to-point. All radio are software defined. In release 1, as I said earlier, the only exception is V1000 cannot do point-to-point in release 1. You could have V1000 with V5000 or V1000 with V5000 to do a point-point, but just between two V1000, that P2P configuration will be supported in release 2. You can do point-multipoint with V5000 as a access point, and you can have a mix for short, mid-range or long-range using V1000 and the V5000, V3000. We can also do the mix of the point-point with point-multipoint, because you probably don't have the fiber in every location, so you can use the point-point to extend the range and then set up your point-multipoint with V5000. Of course, we can also do mesh. When we do the mesh, we use the V5000 to form the mesh layer. The V3000 can also be configured as a DN function to form the long-range connection in the mesh setup. Because you want to mesh on the mesh layer, you want this whole network be continue. So for the long-range connection, we can using a V3000 to form the connection, and the mesh layer will be seamless. It will treat all device on the same function, DN function, to form this mesh. And then you can have the DN, CN under every DN. They act not only to load balancing between DN to DN, it also can be used to serve different CNs simultaneously. So we're using for the mesh specifically, we're using the Telegraph, the Facebook OpenR protocol to achieve the mesh function. So with that, let's talk about range a little bit. So here is a chart. I'm using the run rate. I pick up a location nearby Ottawa. So this is kind of like a reference. Of course, if you're moving to other location, your run rate could be slightly different. You can check our link planner. Then in link planner, we have the run rate accuracy down to 30 meters range in your location. So you can really do a pretty accurate prediction or planning to see how things works. As I said, this is in the suburban of Ottawa with 31.3 millimeters per hour run rate, 0.01% run rate. And I'm using a 4.9 design for this reference. And the left chart showing per direction throughput. Actually, this is a channel with channel bonding. Well, I probably should do a non-channel bonding as well. But anyway, so this one is a channel bonding chart to showing the throughput, and the right chart showing the no rain capacity, because most of the time you during the normal operation you don't have the rain, and we're doing 50 up and 50 down for the thing. So from this one you can see if you're really looking for the top rate, which is MCS 12, it's roughly within the 50 meters. Your capacity will be running on the highest modulation, and within the about 150 meters, you're gonna running on MCS 9, which is basically the single channel will give you 1.1 gig. The channel bonding here showing the 2.2 gig. So the MCS 12, a single channel give you close to 1.9 gigabits. So with channel bonding is 3.8. Okay, so this is MCS 12. MCS 12 about 50 meters. Within about 150 meters, you're running in MCS 9. When we go to the lower modulation, like we said, there are the lowest modulation will be BPSK, MCS 2. It will still give you 380 aggregate throughput. If we do the single channel, it'll be 190 megabits in the lowest modulation. That one you can extend to, in this case, is about 220 to 250 meters, depending on which channel you're using. During the normal operation, you can see the top rate, MCS 12, we'll still talk about 50 to 70 meters. In the 200 meters, no rain, you're able to run it on the MCS 9. If you're ready further down, basically, if we follow a design here in the 200, 250 meters range, no range, you're running on MCS9. This kind of gives the idea about the capacity versus range. Move to the longer range with V3000 as a client node and the V5000 as the host. Similar thing, we're in the 250 meters range, we're running on MCS12. When we move down to MCS9, which is give you basically 1.1 gig without channel bounding or 2.2 gig with channel bounding, we talk about range from 400 meters to close to 500 meters. You will be able to running in MCS9. Go to the lowest modulation, MCS2. We talk about 550 meters. If you're on the channel 4, you will be able to drive to close to 650 meters range. That will be your limitation. Again, if you look at the normal operation, no rain, literally in your normal operation, you always will run on the MCS12 because given most of the planning will be within 500 to 600 meters range. And you can see that will really push you back in here for the MCS12 modulation. For long range point-to-point using V3000, we can see within 500 meters to 600 meters, we're running on MCS12. And when we push down to MCS9, we're talking about 800 meters to about 1,000 meters here for MCS9. And then, of course, if we push down further in MCS2, we talk about 1 kilometers or a little bit push here. It's about 1.1, a little bit here using channel 4. Similar thing with no rain or normal operation. You can see within the 1 kilometers range, you are on MCS12 all the time with no rain. Your normal operation, that will be the throughput you should be expected. If you really want to push the radio extremely, regardless of the link availability, you can see with channel 4, we can really push the radio to about 6 kilometers range for a point-to-point application. So with that, let's see what's really came from Cambium. When we put our design, we really think about the network, not just about a radio. We think about, when you design the network, how we can achieve the best cost of ownership. So we have created this V5000 two-sector design, because in many places, given the mesh setup, given you want to grow your network using 60 gigahertz to the auto expansion, the radio will be not only be a single sector radio. You need one sector connect maybe your existing radio, and then the other sector start to grow from the grow your network. So with a dual sector, all the data will be transferred within the backplane. You don't need a set router to pass the data from one sector to the other sector. And we put everything into the single radio. The benefit is it's very simple, one radio per pole. You don't need to do multiple radios, additional power supply, additional cables, worry about surge protection. Everything will be within the radio. In addition, we have the combination for V1000 and V3000, so we can meet with short, medium range to longer range in the point and multi-point configuration. We can also do long range point-to-point using V3000. Every radio support auto beam forming, so it gives you the easy for installation. It also gives you a peaceful mind after installation. Channel bonding hardware ready, so we're not only worried about capacity I need today, we also give you the hardware which has the capacity to moving double the capacity in the future simply with a firmware upgrade. It's auto rated because 60 gigahertz ready, we're not be able to penetrate into the house. So our radio are auto rated with IP66, 67 rated. High density deployment of V5000 can support 30 devices, and that's really can support high density. Together with the infrastructure we put in there, we can really grow the network, to really meet those high challenge, high density deployment case. cnMaestro single panel for NMS, not only for cnWave, it also for all the Cambium 5 gigahertz PMP device, the outdoor CN pilot, indoor, outdoor, and all other products from Cambium Networks. More than the product itself, we also provide the link planner and AMP tool for easy planning. Link planner today, it support point-to-point already for 60 gigahertz. We are adding PMP function on link planner by end of this month. So you will see the multi-point support very quickly from us. More than that, we also work together with Facebook to offer an AMP tool, the Advanced Network Planning tool. The Advanced Network Planning tool will basically add your financial, the budget information like the set acquisition cost, the operation cost, capital cost for your network, together with the radio characters into the tool. So we can really see, given the budget, given the coverage you want to, service plan you want to serve, what is my optimal network design looks like? You know, if I want to improve my throughput, I want to build more redundancy for the network. I want to, you know, I have more budget willing to chip in for the initial design, and then it will give you a proposal. If your saying is, well, I don't want to invest this much money, I have a limited budget, and this is my budget, and then based on that budget, we're gonna have this ROI model to show you what is the best coverage, or the within this budget, what is the best coverage, what is the best performance, you know, I can achieve, how many radios I can how many subscribers I can cover. You know, that is all built into the AMP tool. AMP tool is not available today for the end user. AMP tool is available from Cambium and from our distributors. So if you have more interest for AMP tool specifically, please talk with MBSI WAV, or you can also check with Cambium sales representative. We're happy to share more details about the tool. With that, Cody, back to you.
Awesome. Thank you, Alan. It was very good, very informative. I don't see any questions yet. So again, if there's anything last minute, please do feel free to pop it in the chat window. I guess right now, though, if there are no questions, we're going to go to our skill testing question. So I'll give everybody just a moment to open up their chat windows. Again, it's first person to answer correctly wins that $100 NHL gift card. All right. Okay, here we go. What is the uniqueness of the 60 gigahertz, the V band, compared to the 70, 80 gigahertz E band? Again, what? Oh, we got our answer. And I apologize if I butcher the name. I think it's, I'm not sure if it's, not sure how to pronounce that name. Oh, hold on a second. Okay, we do have our winner. So thank you, everybody. Julius, I believe. I apologize again if I butchered that name. You are our lucky winner. Again, thank you all for attending today. We appreciate your time as always. If you have any questions, comments, Jeff, we do have, I apologize, I do see a last minute question that came in from Jeff. SON for mesh. Alan, do we need to get a little more clarification on that? I'm not 100% sure what SON is standing for.
So, I think SON, you're referring to self, I think it's called what is SON? Optimized network thing. So so let me try to think what you're asking for. The mesh is a living network. It's not a
self-organizing network is what it stands for. Sorry to interrupt. I just thought I would clarify that for everybody.
Great, thank you. So the mesh really fell to this SON concept because mesh is a living network. It's not a static network. What it does is when we form a mesh, let's say when we form a mesh right now, then based on every link capacity and also latency from the radio to the pop side. In this case, we have two pop sides, right? We have one on the top side, one on the bottom here. So when you have the mesh, every node will based on what is the capacity of every link, and also what is the latency for every link, and what is the usage of every link. And then the nodes will based on those information, the end-to-end controller will based on those information determine what the routing table will be for specific device. So let's say for this device, if it's calculated saying is my best route is going to this way. Let me bring my pen here so it'll be easier. So let's see this one, okay? One possible way of saying is, okay, my best route is this, come to the pop. Then that is, at this moment it will be. In the case, let's say this link is down, then the radio will be recalculated based on what other alternative connection it has. In this case, let's assuming it will go this way. When this goes to this way, it still depends on this link has higher capacity or this link has higher capacity. More than that, what is the usage of those links? Maybe at this moment, this link can go this direction if this link, has even the same capacity has less usage. So it has, when we do the load balancing, the data will go to this way. So there's multiple factors, latency, capacity, usage, and it will determine the routing. When you add a new node, let's say we add a new node here to form the connection, then this new node will bring additional new traffic to the network. And again, it will, it may impact the data go this way, it may go this way, and then the network will be reorganized. So as I said earlier, this SON thing is more about the network has the intelligent, can self-manage the network thing. And that is exactly what mesh achieve here. It's a living network, it's not static. And that really help you to do the auto expansion. And also in the case you have a link failure or hardware failure, the data will be rerouted, give you the better network availability.
Okay, and Jeff just mentioned, Alan, he said L2 or L3 reroute.
So we are, in the first release, we support both layer 3, and we also support layer 2. In layer 2, the foundation still using the IPv6 because the whole thing was IPv, the OpenR protocol is fundamentally it's based on IPv6. But we also do the layer 1 tunneling on top of IPv6, so we will be able to support IPv4. The only one limitation or one restriction is when we do this layer 2 tunneling for IPv4 or layer 2 support, we are limited for 20 nodes. And we are adding this capacity to make the, in the second release, we will be able to support large-scale layer 2 for IPv4. So that is coming. But at this moment, we'll do both layer 2 and layer 3. But for layer 2, when we do layer 2 tunneling, we are limited for 20 nodes. That's the thing you should remember.
Awesome. Thank you, Alan. Jeff had just said good answer. So your breakaway, I'm thinking you probably shelved it. So well done. All right. So I don't think we have any other questions. So we'll wrap up here. If anything comes up, please do feel free to reach out to your MBSI WAV rep, the Cambium reps as well. We're super happy and eager to jump in and help out. Again, thank you to everybody for attending. We really appreciate your time. Any questions, comments, if you're interested in getting a formal quote put together, we do have a nice, concise option spreadsheet that we can work with you to make sure you get every single accessory that you need for your application. Again, if you have any, if you need any information on the 60 gig or any of the other Cambium product offerings, we're more than happy to help out. We will be hosting some more webinars in the future, so we will keep all of you posted on that. Again, thank you so much, Alan. We really appreciate your time. And yeah, we're really looking forward to seeing this product get out in the field. We're anxiously awaiting that stocking order to arrive, but I'm not sure how long it's going to last. So,
thank you, Cody. Thank you for having me here.
Yeah, anytime. All right, thanks everybody. Have a great rest of your week, and we will talk sooner than later.
Thank you.
Thanks
Bye-bye.
all. Bye bye.